This is a Warco WM240B benchtop lathe. It's very similar to the Warco 250, 280 and 290 series lathes. In this video I'm going to show you how I leveled the bed of the lathe and aligned the tailstock, and I'll also explain some of the problems that I had while I was doing this. I've got the lathe mounted to this wooden bench which is 70mm thick, and on top of that I've got this 3mm thick layer of steel sheet. The bench is good and sturdy, but it's not flat or level. So I made these leveling plates for the headstock end and for the tailstock end, and they allowed me to give the lathe a level footing longitudinally and also across the way. And it's level in both orientations, as good as you can get it with a builder's level. I've got a 20mm bar mounted in the 3-jaw chuck, and I've got a dial indicator mounted at center height in the tool post. I'm just going to zero the dial indicator. Now I'm going to tighten up the bolts which clamp the headstock end of the lathe down and see if we get any movement in the dial indicator. Okay, I'm just going to tighten the first bolt. Right, and then the second bolt. Okay, there was no movement of the indicator needle, so by tightening the bolts under the headstock end, the bed hasn't been twisted at all. Now I'm going to repeat the procedure at the tailstock end. Okay. That's moved the indicator needle 130 microns. The tailstock has been twisted in this direction because the indicator needle has come towards me. So because the bed has been twisted like this, I need to put a shim under this side of the tailstock foot. Okay, I'm going to unclamp the bed, and then I'm going to put this 150 micron thick shim under this side of the tailstock foot. Just zero that again. Slid that shim in to the middle of the tailstock foot. Tighten that up. Okay, that's moved 10 microns. So I think I'm going to leave it at that, and I'm going to set up a test bar to take some test cuts on to fine tune the alignment of the bed. Got this test bar mounted up in the lathe. I've turned down the middle section of it to give me a journal at either end. What I'm going to do now is take a light cut on each journal with the cross slide set in the same position. Then I'll measure each journal to see how much difference there is in the diameter at either end. Taken 25 microns off the radius, so 50 microns off the diameter, and I've cleaned up both journals at either end. Let's take a look at what the diameters are, see how they vary. So this end we've got 26 or 260, and this end we've got 21. So there's a 50 micron difference in diameter end to end. So this end is cutting smaller than the headstock end. So that means that the tool is being pushed closer into the work at the tailstock end. So that means we need to put a shim under the same side that we put a shim on before. So we'll try putting another shim under that same side and see how we get on. Put another 40 microns under the tailstock on the far side of the foot. So I'll take another test cut now and see how the diameters come out. That was another 25 micron depth of cut, so I took 50 microns off the diameter. Okay, the reading I'm getting there is 25. And the reading I'm getting there is 20. Okay, so that doesn't seem to have made any difference, so I need to try again. Okay, this end we've got, that's reading 13. Mm, 13.5. So there's a 5 micron difference from end to end. I'm going to call that good and leave it at that and say that the bed is leveled. Now that we've aligned the bed of the lathe, we can move on to the tailstock alignment. To help with the tailstock alignment, I've made up this test bar. This is made out of a 20mm diameter length of silver steel, which is about 330mm long. And it's perfectly straight and its diameter is perfectly consistent along the length of it. To make the test bar, I bored the centers in each end, and I bored the centers instead of drilling them so that I know that the center is perfectly concentric with the OD of the bar. To make the test bar, I used the method described in this book. It's on page 105. It's a good reference. So we'll mount the test bar up between centers now and use a dial indicator to adjust the tailstock alignment. The method described in the manual for adjusting the tailstock alignment is as follows. You unclamp the tailstock from the bed by loosening this lever. Then you undo this grub screw and loosen it half a turn. Then you can use the 2 Allen head bolts on either side of the tailstock to adjust the alignment. You can use this scale to ensure that you get the alignment where you want it. If you turn the Allen head screws in a clockwise direction, as viewed from this side of the lathe, the tailstock will move towards you and vice versa. When you've got the alignment set, you lock down this grub screw and then you tighten the 2 adjusting screws against each other. The reason they want you to unclamp the tailstock from the bed before you adjust it is because the clamping mechanism clamps the upper part of the tailstock to the lower part of the tailstock. So if you try and adjust the alignment with these 2 parts clamped together, there's a lot of friction there. I'm going to show you one of the issues that I've noticed with the tailstock. First I'm going to unclamp it from the bed. I'm going to slacken off this grub screw. I'm going to undo this adjusting bolt. So you can see that there's a lot of play between the upper and lower parts of the tailstock. The tolerance between them seems to be pretty poor. The lower part of the tailstock seems to have a good fit on the bed though, which is good. I think the loose fit between the upper and lower parts of the tailstock explains why the manual suggests you should lock this grub screw before you tighten the adjustment bolts against each other. What you're essentially doing by tightening the grub screw is taking any play between the upper and lower parts of the tailstock out. I'm going to take the tailstock off the lathe and get it on the bench to see if we can improve the fit between the upper and lower parts. I've got the tailstock here upside down on the bench. So let's take it apart and see if we can improve the fit of the upper and lower parts of it. Let's get a dimension on this rebate. So it's 32 millimeters nominal. Yeah, and that's fairly consistent. Get a dimension on this. Okay, so that's 31.5 nominal. So there's half a mil of difference between this and this. So we can try and take that up with some shims. So I'll dig out some shim stock and see if we can get something to work. Okay, I've got these two bits of shim stock. Just under half a millimeter, the two of them together. So we'll see if we can fit these parts back together with these shims between them. Okay, I can fit the shims in on that side, no problem, but I can't push them all the way through. On this side, I can just barely fit them in, so I think that's going to be too tight with those two shims. Okay, I've got these two shims and together they're about 420 microns, so that's 60 microns less than the other two shims together, so perhaps we'll fit these in. Okay, that fits in no problem on that side. Okay, I think that's going to work. And it's significantly reduced the amount of play between the two components, so that's good. Off camera, I've done a bit of deburring and cleaning of these sliding surfaces. Now we can put the tailstock back together. got the tailstock mounted back on the lathe. I'm going to show you the method that I've developed for adjusting the tailstock, which is slightly different to the method outlined in the manual. So we'll get the test bar mounted up. We'll lock the tailstock to the bed. Wind the quill in. Light pressure on the bar. Lock the quill down. Wind the indicator to the headstock end. It's zeroed there. Wind it to the tailstock end. Check how far out it is. Okay, it's 130 microns out. So now what I'm going to do is I'm going to unclamp the tailstock from the bed and then just very loosely clamp it down. Next, I'm unlocking the grub screw at the back of the tailstock and then just snugging it up to remove any play in the two parts of the tailstock, the upper and lower part. Okay, now with the tailstock unclamped from the bed and that grub screw undone, remember from before that it needed to move 130 microns and it's pretty much still on that. So it needs to go 130 microns away from me. So that means I need to turn these adjusting bolts anti-clockwise. Okay, just tweaking them. Right, before we get to zero, I'm going to lock the grub screw on the back of the tailstock. So we're on 20 microns at the moment. If I lock that down, you can see that it's probably moved the indicator needle probably about 5 microns. So that suggests to me that I need to get the indicator needle about 5 microns beyond the zero before I lock it down. Otherwise, when I lock it down, it's going to move the needle and the tailstock will be out. Okay, that's just about 5 microns beyond zero. So now I'm going to lock the grub screw at the back. And with any luck, that'll bring it into zero. Which it has. It's just gone beyond zero, but it's good enough for me. So now we'll lock the tailstock to the bed and readjust the quill, light pressure, lock the quill down. Okay, so you can see that we're 40 microns out. So the tailstock needs to go 40 microns away from me. So it's a rinse and repeat until we get it landing on zero when we relock the tailstock down. So that's the method that I've developed for adjusting the tailstock. You have to do it iteratively because every time you've got to unlock the tailstock from the bed, adjust it by the amount you think you need to adjust it by, lock it back down again and just check it again until you home in on getting it on zero. Okay, we'll wrap this video up there. Maybe it's been useful to someone out there on the World Wide Web, or maybe it'll just be useful for me the next time I adjust the tailstock. Cheers.